Hello everyone. Today let's solve the problem number 138, copy list with random pointer. Right. So here they have already given the definition for a node. So we don't have to include this one within the class here. Right. So we don't have to include the class node within the class solution. So let me remove this one. So basically they have what they have done, they have declared the class node globally, right? So they have declared that one globally, so we don't have to involve this one, the same thing within here, right? So now let's do one thing. We are going with the this one. We are discussing the problem number 138, copy list with random pointers, right? So let's see what the question states here, right? So we are given a special linked list where each node has the next pointer. We have been given a special linked list here. So just give me a second, 1 second here. So yeah, we have been given a special linked list. We have been given special linked list, right? Where each node has next pointer, which each node has next pointer and a random pointer that can point to any node in the list. A random pointer along with the next pointer, there will be a random pointer which points to any node, and also it can be null, these are the two conditions that they have given. One thing is we will be having the next pointer for sure, and another one is we will be having the random pointer that points to node or null, right? So these two things we have to keep in mind, right? So one thing, we have been given a special linked list where each node has the next pointer, and another one is a random pointer that can point to any node in the list or null, right? So these two things we need to keep in mind. So what we need to do here, based on the question, we need to create a deep copy of the such list. We have to create a deep copy of such list such that all nodes are new. All nodes are new. We must create a deep copy of the list such that all nodes are new. So whatever the deep copy means, the nodes that we create has to be new. We shouldn't go with the in place modification. Instead, so suppose here we have 1 and 2. So this is just the example, right? So suppose if we are this one, what do we call, creating the deep copy of it. So same thing we need to do, but we are creating the new 1 and 2 here, new 1 and 2 within the list. So that creates the deep copy. That is the meaning of deep copy, right? So don't get confused here. So they are saying here, just let me remove this one entirely. So we must create the deep copy of each list such that all nodes are new. So let's come to the example part here. You'll understand this one even better. So here this one input head we have 7 null, 13 0, 11 4, 10 2 and 1 0, right? So we shouldn't go with the same thing. We can return the same thing here, right? So we'll get the same output. So return head, we can just go with the return head, we'll get the same output. No, it doesn't happen like that basically. So we have to go with the deep copy meaning that we have to create the new node. Here it has to, we have to create the new node, and the value 7 has to be present in that node. Same goes with null, 13 0, 11 4, 10 2 and 1 0. Same goes with all the elements, right? So that is the meaning of the deep copy basically. We must create a deep copy of this list such that all nodes are new. Both next and the random pointers replicate the original structure without using old nodes. So this point is very important. Both next and random pointers replicate the original structure without using the old nodes. So just keep this in mind. Both next and random pointers replicate the original structure without using the old nodes. Just keep this in mind. This is very important, right? So we are done with the question. I hope the question part is completely clear. Let's come to the first example here. See, so as we have to create the deep copy of the head, so we don't have to worry about the this one, derivation of the output, right? So here in this case we have to get the same output as input, but the nodes has to be new. As we are creating the deep copy of it. Same goes with the second example as well. 1 1 2 1 will get the same output. Third input as well. So third example as well here. 3 null, 3 0 3 null. The same thing here. 3 null, 3 0 3 null. So I hope this part is completely clear, man. Right? Easy to understand. Let's do one thing. As we are completely done with the question part, let's move on with the this one, approach followed by the complexities, and then let's write the code and this one. Then let's write the code. Before hopping into writing the code, let's discuss the approach followed by the complexities first. So let's come to the approach part. So here, let me come here. Let me scroll. Just give me a second here. Let's consider the first example for the approach, man. Yeah, right. So this one. Let's consider the first example for the approach, right? So here we'll be considering this one. Head equals 7 null 3 13 0 11 4 10 2 and 1 0. Right here first, we can represent this one like this. So first we have the input, we are considering the input, this one, head equals this dash dash they have given, right? So we can denote the nodes in this way, right? We can denote the nodes in this way: 0 7 0 7, and here 0 7 null, sorry, null we have been given, right? 7 along with the null within the pointer. And here random, so in the question they have given random pointer can point to any node or null. These two conditions they have given: either the random pointer can, this one, point to any node, or it can point to the null, right? So here in this case, first initial case, it will be pointing to null. I'll just write this one in the small n, right? So this will be denoted by small n, null. So next let's go with the 1 and 13. We have this one, sorry, 13 and 0, sorry, I got confused here. 13 and 0. So here this one will be first index, so this is 0th index, this is first index, right? This one will be 13 0, this has to be 13, this has to be this one, this will be instead of the this one 0, this will be 11, this will be basically 11, right? So this will be 11. So random will be 0 here. Random will point to, random can point to any node, and or it can be null as well. Random will point to 0 and will consider 11, right? So 11 1. So let's come to the second one, second index. Now this has to be, we have to consider, we are done with these two, we have to consider 11 and 4, 11 and 4. So 11, this will be 11, and this one will be previous, this one, index 1 and 0, 0 that the random was pointing to, and random will be quite obviously 4. You know that this one we are considering the right one, random will be 4. Previously random was 0, this time random will be 4. Let's move on with the third, this one. Let's move on with the third, what do we call, index. Now this we are considering 10 and 2. So no, now you have guessed this one right, right? Now you have guessed this one right. So this will be 10. This will be 10. So this will be 10, and this will be right side one would be 1, 1, and random would be 13 and 10 and 2 we have, random would be 2, right one. Random consists of the right element, right? Among, if we consider x, this one as x and this one as y, random always consists of the y. Random always consists of the y. For this one, we have considered null, random as null, and the null, this one. This can point to any random, this one. This can point to, uh, random can point to any, this one, what do we call, any pointer, any node basically, right? So we can just consider 11, 10 here, this one as 1 as well. And let me consider fourth index now. What we have, the last one, 1 and 0. So here we have 1 which is pointing to this one, 1 which is pointing to null basically, null, right? So random we will consider 0, random we will consider 0. Don't get confused with the null 1 10, it can point to any node, it can point to any node. Don't get confused with this, right? So just focus on this part, index along with the random pointer, right? This one I'm speaking of, right? So I hope this part is completely clear, man, right? We have just denoted this one like this. Let's go with the first step here. We will clone the nodes and insert them to the original. We will clone the nodes and insert them to the original, right? So here what we'll do, this one we will consider the left part 7 13 10 and 11, 7 13 11 10 and 1 we have, right? So this would be 7 13, this would be 11, this would be 10, and this would be 1. So let me give the arrow mark as well. So this would be, so we are cloning this one, this will be present twice. So this will be 7 7 13 13. So 13 13 this will be 11 11, and this one would be 10 10, and this would be 1 1, this would be 1 1, right? So I hope this part is completely clear, man. Let me delete this one, I'll tell this one. I hope everything is clear. So we have now 7 7 pointing to 13 13, this one pointing to 11 11. So next, this one points to 10 10. Next, this one points to 1 1, this one points to 1 1. This is fine. So the next part is, let's move on with the next step. Nothing but we will be assigning the random pointers to the cloned nodes. We will be assigning the random pointers to the cloned nodes. So here in this case, 13's random number was, I deleted that one, so you can just go to the video where I where we had 13 pointed to 0. 13 pointed to 0, right? 13 pointed to 0, the right one. Random was pointing to the right one, this one 0. 13 is pointing to the 0, right? So here 13's random is equal to 0. We know this one right here by this itself, right side, right one. 13 pointing to the random 0. So point here as 13 dot random equals 7. 13 dot random equals 7. This we can represent in this way: 13 dot this one random, this one equals 7, equals 7. Just for the sake of example, I have shown this one. 13's random equals 0. So point here 13 dot random 7 we can consider. So we can rewire original next and collect cloned list separately. Here the final step is we have to detach the cloned list from the original. After detaching the cloned list from original, we get the same output here. We get the same output, nothing but 7 null in this case. Next would be 13 0. Next would be this one 11 4. This one would be 10 2, and final one would be this one 1 0 1 0. So this is the output that we will get at the final step. Third step, we have to detach the clone list from the original, or you can consider like this: after detaching the clone list from the original, we rewire original next and collect the clone list separately here. So this would be the output. This would be the output, this one, right? I hope this part is completely clear. So we'll get the same output, we'll get the same output after performing these operations, right? Just give me a second here. Yeah, let me remove this one. So now we know the approach. Now we know the approach what we are going with, right? So first step was we were cloning the nodes and inserting them to the inserting them next to original, right? So next, after doing that, what we did, we assigned the random pointers to the clone nodes. Just a random pointer, it can point to any node. We don't have to worry about that. It can point to any node in the memory. Just you don't have to worry about the right part that I wrote initially. So I showed the same thing in the approach, and I said multiple times that we don't have to worry about it, right? It can point to anything. So the third step is we have to detach the clone list from the original. Cloned list, we have to detach the cloned list from the original because we have to return that one in the form of output, right? So we have to return new nodes, not we shouldn't return the same nodes that were present in the head, right? So we can directly return the head, right? So but they have asked us to go with a deep copy. We have to create the new node, and the values has to be present same, and the values has to be same basically, right? So that is the reason we followed these steps, right? First step was clone nodes and insert them into the original. Second step was assign random pointers to the clone nodes. Third one was detach clone list from the original. So these were the three steps basically, right? So these were the three steps. I hope this part is completely clear. I hope this part is completely clear. Right, next what shall we do? Before hopping into writing the code, let's do one thing. Let's discuss the complexities quickly and then let's write the code, right? So what will be the time complexity here? The time complexity would be big O of n. So the time complexity would be big O of n. So here when I say time complexity is big O of n, uh, we are traversing the list three times, each in linear time. Three steps that we discussed, right? Three steps that we discussed, we are traversing the list three freaking times, right? Each in the linear time. So overall time complexity, each step it will be big of n, each step will be big of n. So each time so overall time complexity we can just consider big of n. We know this one, right? We are traversing the list 3 times, each in the linear time, so overall time complexity would be big of n. So what would be the space complexity here? The space complexity would be big of 1, because we are not making use of any extra space for maps or arrays, right? So we are not making any extra space for maps or arrays, we are just manipulating the pointers here, we are just manipulating the pointers here. So the space complexity for this problem would be, or the space complexity of the code that we'll be writing in the future would be big of 1. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big O of 1, right? I hope the complexities part is completely clear. I hope the complexities part is completely clear, right? So now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So here, let's do one thing. First step here is, if the current I mean, if the head is null, means if we don't have any elements within the list, then we have to return null. Quite obviously, we don't have any elements at all, the base case. So let me write here, if head equals null, then we have to return null. I hope this is clear. So the next step is, let's uh, let's go step by step here. Let's move on with the further steps. Step 1, we have to clone the nodes and we have to insert them right after the original nodes. So we have to clone the nodes and insert them right after the original nodes. So here in this case, this would be node current equals head, current equals head. So this is fine. So the next step, let's go with the while loop here. While current not equal to null, so then within the while condition, what shall we do? Let's create a new node with the same value. Let's create the new node with the same value. So here in this case, this would be node clone equals new node of, so let's pass the value for the current dot value. So this is fine. We are just creating the new node with the same value. After creating the new node with the same value, we have to link the new nodes next to the originals next. So this would be clone dot next equals current dot next. So this is fine. So the next part is, we have to insert the clone after the original, nothing but here this would be current dot next equals clone, the final part as we had discussed. So this would be, we have to move to the next original node, nothing but current equals this one, clone dot next, current equals clone dot next. This is fine. So the next step would be, second step, what we discussed, basically we have to copy the random pointers to the clone nodes. We have to copy the random pointers to the clone node. Here on this step, it would be current equals head. Let's go with the while loop here. While current not equal to null, while current not equal to null, then let's go with the simple if condition here. Current dot random, current dot random, if it is not equal to null, then what shall we do? Let's go with the clone dot random, or let's assign the clone dot random to original dot random dot next, nothing but the clone of the random, the clone of the random, it can point to any pointer, so we don't have to worry about it. So we can write this one in this way. So this would be current dot next dot random, this one will be current dot random dot next. This is fine. I hope this part is clear, right? So the final part in this step would be, we have to move to the next original node. We have to move to the next original node. In this case, it would be current equals current dot next dot next, current dot next dot next, right? So we are done with the step 2. We are done with the second step. So if you remember, what is the third step? What is the third step that we discussed in the approach? Basically, we have to separate the clone list from the original list. We have to separate the clone list from the original list. When I say we have to separate the clone list from the original list, it has to be node dummy head equals new node. We are just considering the dummy man. So most of the times, as I have said, we will be going with the dummy node, the dummy node for the simplified edge cases. To simplify edge cases or to solve the problem easily, we will be going with the dummy head. In the trees, we can go either with the BFS or the DFS with recursion especially, right? So we will be making use of the recursion for most of the problems while we are solving the problem on trees. The same thing goes with this one, what do we call linked list. Most of the times we'll be making use of the dummy node, right? So I have said this one multiple times while we were solving the linked list problems, right? So while we are solving the linked list problem, so here it would be new node of 0 in this case. So after inserting the dummy node to form the new list, then let me do one thing. Let's make use of the copy current variable and assign this one to the dummy head, right? So here this would be copy current. I'll just give CURR. Yeah, let's assign this one to the dummy head, sorry, not dummy node. So let's assign this one to the dummy head. So I hope this part is clear, man. Let's assign the current to head as well. Let's assign the current to head. So this is fine. So let's go with the final step here. Current should not be equal to null. Current should not be equal to null. Then only we can proceed with the further things. So here this would be current not equal to null, and within this while loop what we have to do, we have to get the clone node first. We have to get the clone node, meaning node. So this one clone equals current dot next. The next step is we have to append to the clone list. We have to append to the clone list accordingly with the approach. So whatever we discussed in the approach, that itself we are articulating in the form of code here, right? So we are appending to the clone list. So how can we write that one in the form of code? So I'll just write here copy current dot next. This one let me assign to the clone. This one let me assign to the clone. Finally, let's assign copy current equals clone. Copy current equals clone. This is fine. So the we are done with the we are left with the last two lines, nothing but if you remember the approach, we have to restore the original list next basically. Yeah, we have to restore the original lists next, and also we have to move to the next original. After also we have to move to the next original. These two things, we are left with these two things. So let's do, or let's implement the same thing in the form of code now. So to restore the original lists next, we have to go with current dot next equals clone dot next. So this is fine. This is fine. So the final line here is we have to move to the next original. Nothing but I'll assign current to the current dot next. I'll assign current to the current dot next. We are done. We are done with the logical part. We are left with only one thing. Nothing but we have to return the head of the clone list finally. We have to return the head of the clone list, means dummy head dot next. We have to ignore the dummy head. We have to ignore the dummy head, means dummy pointer. This one pointer we have to ignore the dummy node basically. Every time we consider the dummy node, most of the times we have to ignore the dummy node, and we have to uh, start from the next. We have to start from the next value that is present, right? So initially we call it that one head, right? So we have considered, instead of dummy, we have considered the variable name dummy head here. So we will go with dummy head dot next, means we are returning the head of the clone list finally, right? So I can just articulate in the form of code in this way. I can just return dummy head dot next here. So this is it for the code. This is it for the code. So what I did here, yeah, let me format the code once. So we made use of the linked list operations here. We made use of the linked list operations. This is completely based on the list, right? So we made use of the linked list operations here to solve this particular problem. Basically, this problem is not asking us to do anything special. We have to just deep copy. We have to just deep copy the this one values that were present in the initial list, and we have to return the new one. In the simple sentence, it is asking us to do the same thing. We have to deep copy, and we have to deep copy the list, and we have to return the same value, but the pointers has to be new, but the nodes that we are creating has to be new, right? So this is what this problem is asking for us to do basically, right? So we are done with the problem. We are done with the problem. Let me hit the run button. I have formatted this one. Let me hit the run button. So here we have the error class interface enum or record line number 38. So what error we have here? Why? Just give me a second here. 1 second. So I think here I have done one mistake. So here, why this is closed has to be, this has to be open right here. So one extra bracket I have given. So this is giving the error, I guess. So let me hit the run button now. Compile error. We have new node. N has to be capital here. This one, line number 9. So yeah, this has to be in capital here. So let me run this one again. So I hope this works now. Let's see. Yeah, now we can clearly see the sample test cases are getting passed, right? The sample test cases are getting passed. So let me hit the submit button quickly. I hope this works for all the test cases, man. Let's see. So you can clearly see here all the test cases are getting passed, means the code works absolutely correct in this case, right? So I hope whatever the code that we have written is completely clear. I mean to say, I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.